Find all rational zeros. Okay. So, well, let's do it anyway. That's a good review because you have to do that on the test on Tuesday. So I give you something like that, and I say, find all zeros, real and imaginary, if there are any. So the first step you want to do is make a list of possible zeros. List of possible zeros. What is your P and what is your Q? Your P in this case is 2, and the Q is what? 2 over 1. The leading coefficient is 1. So you find all factors of 2 and include the positive and the negative one, which is 1 and 2. And of course, all factors of 1 is just 1. So my list of possible zeros plus minus 1 and 2. So there are 4 of them. And then you start with the number 1. I'm telling you, start with the number 1. So we're going to start with x equals 1, and we're going to do synthetic division. I'm not going to have you find some outlandish zero there that's 13 or 17. You sit here all day. We don't have all day to take a test. So it's something simple. It's either 1 or negative 1. And of course, and I said that before, your final exam and probably a question on the test, I still need to finalize it, is multiple choice. So if you are being asked, okay, I'm digressing here. We get to it, Tony Ann, just a second, but I want to get my point across. If you're being asked to find all zeros, and your answer for A is 2, 3, 4, your answer for B is 2, 5i, negative 5i, your answer for C is 2, 6 and 7, and your answer for D is 2, 7 and 8, don't start with 1. 1 is not a choice here. You see what I'm saying? Multiple choice test. You have the answers in front of you. So if you're being asked to find all zeros and you have this big polynomial over here, and I say start with 1 because you have nothing else given. But if you have the answers given here, you want to start with the number you see like in all 4 or in 3. And 1 is not a choice. So don't use 1 or negative 1 for that matter. Right? Be smart about that. Don't do, obviously 1 is not there. So start with, what would I use to begin with? 2. Because look at that. I mean, that's pretty obvious because I put 2 in all of them. Well, let's just make 1 minus 2. So look at the mode. You have 3 2's there in 3 different answers. You can be almost 100% sure that 2 is a 0. And once you have 2, you do your synthetic division. And then you're going to go back and you do quadratic formula or whatnot to find the rest of the story. Okay, back to our problem here. So we're going to start with 1. We're doing synthetic division. We have 1, 1, 2, and 2. And once we're done with that, I actually show you a different way we could have done that problem. We're going to do 1. Bring down the 1. 1 times 1 is 1. Don't get confused. Maybe you want to write this down. The arithmetic multiplication table is pretty simple. You add and you get 2. Then you have 2 times 1, which is also 2. You add and you get what? 4. And then you do 4 times 1. I can already see that's 4. So 1 is not a possible 0. And that's how you do this on the test. You start with 1. If your remainder is 0, congratulate yourself and finish it up. In this case, it's not. So I'm going to erase that. And now I go to -1. And see if -1 works. -1. And that's what you do on a test. It's either 1 or -1. I can't have you figure it out too long. This is a -1, which is 0. 0 times -1 is also 0, plus 2 is 2. 2 times -1 is -2. Oh, what do you know? Here we go. Life is good. Okay, so we found one. Guys, you're with me. Now we got to look the initial one, the original polynomial was to the 3rd power. We have to bring our variables back in. In my last row is the quotient, and this quotient is 1 degree less than the original, so this one starts with x squared. Then we would have an x here, and then we have nothing. And you can put those x's back in so you don't get confused. So what I have left is x squared. I don't write 0x because that's 0, and plus 2 equals 0. That is now what you have to solve. This is the rest of the story, the green stuff. Now the book says, find all rational zeros. You are actually done. The rational 0 was the -1, a rational number, real number. These guys in green are going to be complex numbers, imaginary numbers. You're not even being asked to find them, but we're going to finish it because we're going to review for the test. -2 minus 2, so x squared equals a -2. Then you are taking the square root, and x is equal to what?
I square root.
Plus minus I square root of 2. And this is an imaginary number. That's why you don't see that in the book. The book is just asking for what are the rational zeros. So the answer here to this problem, the zeros are x equals -1, negative I square root of 2, and positive I square root of 2. You can just say plus minus. But these two are not rational. That's why the book only has one answer. Does that make sense? Yeah. What did I say in my intermediate algebra class yesterday? Whatever you're doing on the phone, you have to share with all of us. Yeah. Yeah, they were not too happy about that. Okay. Tony Ann, make sense? Any other questions? Homework questions. Okay, Ethan, let's hear. It's a good
71.
71 and 3.4?
Yeah.
Let's see if I like it. 71. X to the 5th? Find all rational zeros. If necessary, use the depressed equation to find all the roots of the equation f of x. Oh.
What fraction is this in?
3.4. That was a homework problem?
Yeah.
Okay. 71. F of x equals x to the 5th minus 2x to the 4th minus 4x to the 3rd plus 8x squared plus 3x minus 6. Yay! What was that? I don't know. That didn't sound right. Okay, for you people who listen to that. Oh, that's even worse. Okay. I was just thinking about some. Anyway, P over Q. Let's make a list. P over Q. P is 6. Q is 1. So all our possible zeros here list is 1, 2, 3, and 6. And this is to the 5th power, so believe you me, we have to find 5 of them. We haven't done a 5th one, but let's just go through one of them and see how much fun that can be. Okay, so we're going to start off with a 1, a -2, a -4, an 8, a 3, and a -6. There's no missing term. Everything is in descending order, and we're going to use 1 and see what happens. 1 times 1 is 1, minus 2 is a -1, -1 minus 5, -5, 3, 6, 6, 0. Oh, what do you know? Okay, so we found 1. Only 4 more to go. Now what you would have to do is do synthetic division again. So your p-value is 6 again. And your first one is 1. So the list still holds. So you basically, if you have to make a new list, you make a new list of possible zeros. And we're going to start with 1 again. I'm just going to draw a box around the red ones and start with 1 again and see if 1 works here. 1, what?
Why are we doing synthetic division again?
Because this polynomial is to the 5th power. We have to bring it down to something to the 2nd power. So you have to do continuously synthetic division until we're down to we can see something, say something, and
Are you using the numbers that you got? Like the -1, -5?
yes, I'm using the red numbers. The red numbers are now used to do synthetic division again.
And if this one works out again, does that mean it has a multiplicity of 5?
Yes, it would mean that. Let's find out. 1 times 1 is 1. I almost said 2. 0. 0, -5, -5, -2, -2. We can already see 1 is not 1. Okay, then you would go to -1. And maybe I gave you this for homework because you couldn't do this during a test. It takes too long. -1 is -2, +2 is -3, +3 is 6, -6 is 0. Oh, what do you know? Yeah.
It's just minus.
Yeah, there is an answer from planetmath.org. What is the answer? Let's ask Alexa and see what she says. She, he, it. Okay, so we had an x to the 5th here. This became an x to the 4th. Now we are down to an x to the 3rd. And now we could either do synthetic division again, and we would start with 1 again. Okay, let's do it. I'm just going to do 1 because I got to save some time. I got to do some other things. I'm going to do 1, and I'm telling you that 1 doesn't work. But we still have a 6 again, so my list of possible zeros is still the same. So 1, -1, -1, -4. You can see it's not working. 1 doesn't work, and guess what? -1 doesn't work either. Okay, that's why it's homework. -1 doesn't work either. Then you go to the next value in your list, which is 2. So now we're going to do 2. And we use green, so 2. So 1 times 2 is 2. 0, 2 times 0 is 0, minus 3. Oh, what do you know? 2 worked. Okay. See how this worked? Beautiful. I used to sit there all afternoons plus you to do synthetic division because my teacher didn't use 1 and 2. My teacher used like 17 and 21 and 49. Anyway, This green last row here is now to the second power. So we're down to the second power, and that x squared 0x minus 3, we're going to solve by any method that we know. I'm going to use square root property. Add 3, get x squared equals 3, take the square root, x equals plus minus square root of 3. That is a great problem. So the zeros, we found all 5 of them were 1, -1, 2, negative square root of 3, and the positive square root of 3. And that wasn't all that bad. I like it. 20 problems like this on the test. No. But if you have more line to the third power, if you have something to the fifth, to the sixth power, and that was another thing my instructor used to like to do, he had us do like x to the seventh power or x to the eighth power. So then you have to find 8 zeros. And you sit there all afternoon and trying to figure out synthetic division. That was way before the computer, the calculator, you know. We actually had to sit there and try to figure this out. No computer there for us to plug into Desmos. Yeah, no Desmos. Going on in the 19th, I'm not telling you which year. But, yeah, so now we have that. If you could plug this into Desmos, and you can see the zeros, and then you can work backwards. Speaking of, let's do this one more time, perfect lead over. And if you have another question, hold on, we can do one later. But I just want to practice this one more time. I don't know, it was 63 or 57, and then neither one of them I wanted to do. Perfect lead over if you have the zeros. Let's just say I want you to find a third degree polynomial. And I gave you a handout. Yeah. Let's take a look at number 8. Did we do that already? Who else needs one? We have one. You were here. Weren't you guys here? Yeah. I think we did number 8 already, but we could write it out again. Number 8 was write the equation of least degree with the given roots, or in other words, find a third degree polynomial. Yeah. Find a third degree polynomial with the given zeros. And the zeros are x equals -3 and x equals 7i. The first step is to write these zeros into a factored form. Factored form, what would be the factors if -3 is a 0? What is the factor? X plus 3. Always opposite of what you see. If 7i is a 0, what is the factor? Why is nobody speaking now? Thank you. X minus 7i. What did I say on Tuesday? They travel in pairs. So go ahead.
X squared minus 7.
Well, no. So if they travel in pairs, I meant that x plus 7i, the conjugate, is also a 0. And that's how you get your third degree polynomial. You only have 2 given on the test. You need to remember that there's a third one. And if you were to multiply this out, do the conjugates first, because what happens is the I disappears, and you get x squared plus 49. Remember in intermediate algebra when you were told that sum of squares cannot be factored? Well, it can't be factored into real numbers, but it can be factored into x minus I. And then we go ahead and multiply by x plus 3, and that will give us our polynomial. X squared times x is x to the third. Oh, there's your third degree polynomial. Plus 3x squared plus 49x plus 47? I believe it. $49 times 3, $147, right? Yes, no, maybe so. Yes.
Is there a reason why you put a P there instead of F of X?
No, I just called it P for polynomial. You can write f of x. I just gave it I wanted to be different today, yeah. We say f of x all the time, I got tired of it. Absolutely no reason, yeah. P for polynomial, and that's it. That's your polynomial, and that is the polynomial in expanded form. While we're at the handout, let's take a quick look at number 9. Ooh, I like that problem. Number 9 on the handout says, sketch a 4th degree polynomial with a positive leading coefficient, a double zero at 2, and a double zero at -3. Ooh, what does that all mean? I'm making some really strange noises today, so if you watch this, listen to it. Just mute myself. A 4th degree polynomial with a positive leading coefficient. What do we know about the end behavior? Up. So you should make sure that you get that right. Then we have a 0 at 2, and we have a 0 at -3. I call them double zeros. So that means the multiplicity is 2. So I wish we had a board. Somebody wants to draw that? I guess I do. How is this going to look like? Do we touch up or touch down? We have no chalk either. So we're gonna... this is not good. We're gonna touch up like so. We're touching here as well. So the rest, you can do whatever you want to, as long as they are going up over here and over here. At some point we gotta cross. Where you're gonna cross is totally up to you. You can.
Just touching?
What?
Why is it just touching?
Because I said I want a double zero at 2. Double zero means the multiplicity is 2. And when the multiplicity is even, it's touching. It's touch and go. And there's a double zero at -3. Oh yeah, those questions I like. Yes.
Would something like that be like that? Just curious.
What did I just say? I said I really like them.
Okay, got it.
So I'm picturing a lot of these problems.
Okay. Okay. Oh, yeah. Okay. Thought you had a question. But no. Yeah, me too. Me too. I could give you 100 questions on this. Yeah. Okay, number 10 is pretty straightforward, right? Use synthetic division to find the quotient and the remainder. That's all you have to do. You do synthetic division. What you need to remember, and Logan, I like those questions too, a lot. What you need to remember, if there's a missing term, and I ask you to do synthetic division, what do you have to do?
Put a zero.
You have to put a 0 in there. Real quick, let's do one up, make it one up before we go into 3 point, wherever we are, 3.6. I want to do 1 or 2 things. Okay, we're back to the f of x. No, not even that. Okay, divide, use synthetic division. Divide 3x to the 5th minus plus, okay, be that way. 2x, 3 minus 6x squared plus 5 divided by x minus 2 Here you go. What is the quotient and what is the remainder? And for the most part, synthetic division is pretty straightforward. I mean, it's multiplication. It's easy to make a sign mistake, blah, 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 blah. But you're going too fast, so you don't even pay attention to what I wrote there. A lot of students on tests write out the coefficients. Oh, I know this. I know how to do this. This is so easy. 3, 2, 6, and 5. Many times have I seen that you didn't, not you because you will make those mistakes, but in the past students have made the mistake, A, you're looking at missing terms here, and you also have negatives. You gotta carry the sign with you. So if I do synthetic division, what are my coefficients here? 3, 0. See? Yeah, see? Negative 6. You said 6. 1. Yeah, that's another good one. Yeah, I've seen them all. So, couple mistakes can be made. Students forget the negative, the term, the sign goes with them. Students forget the placeholders because it's so easy compared to find the inverse of parabola, you know, right? Yeah. This is much easier, I hope. And then we have x minus 2. Oh, Logan, another thing I like. What did the student do wrong?
It would be 2 because I got there.
I see that all the time too. I just showed you all the most mistakes students have made in the past. Forgetting the placeholder, forgetting the negative, and just looking at this and say negative 2 instead of positive 2. Okay, let's see what's going on here. I have no idea. First step is, that's another mistake. They just write 2 down. I've seen it all. 2 times 3 is 6. Plus 0 is 6. 6 times 2 is 12. Plus 2 is 14. 14 times 2 is what? 28 minus 6 is 22. Please use a calculator. 44 plus 0 is 44. 44 times 2 is what? 88 plus 5 is 93, and that is your remainder. So what would be the quotient here? 3x to the 4th.
Plus 6x to the 3rd. Plus 22x.
22x.
44 to the 8 is 93.
Right. Here you go. Beautiful.
On these, do you always use the opposite sign of what's in there, or do you just take it?
You always use the opposite sign of what is your factor. Yes, because that is a factor, remember, and the 0 is opposite of that factor. And obviously, then I could be asking you, is x minus 2 a factor of this polynomial? What do you say? No. And then I could be asking you, is 2 a 0? What do you say? No. For that to happen, this has to be a 0. Okay, cool. Those are all good review problems. Now let's take a look at some 3.5 and 3.4 is basically the same. 3.6. 3.6, not that. That's not what I wanted to look at. 3.5. Do I have 3.6? I thought I had something. I saw something, so I don't have to write it down. Let's take a look what's in here. Here you go. There it is. 3.6 is on rational functions. Now, we've already talked about rational functions, so more or less that will be a little review, at least the beginning. A rational function is if you have a polynomial in the numerator and a polynomial in the denominator. The book calls these polynomials n over x, n of x over d of x. This is just the label of polynomials. Now, here are some examples. We kind of talked about these already, like x plus 2 over x minus 1. What is the domain here? How do we find the domain? How do we find the domain of rational functions? We've done this already. You had a test on that. You said what? The denominator, but you are right, d of x, the denominator, equal to 0. So in this case, the denominator is x minus 1 equals 0. How did I call this again? I called this the restricted value. We solve for x and we get x equals 1. That is the restricted value. That means the function is not defined at 1, but it's defined anywhere else. So how did we write the domain down? Right, here you go. That is the domain. But this restricted value now is also what is called a vertical asymptote. We get to that in the next slide. Let's find the domain of 3 over x minus 4. What is the domain? Negative infinity to 4, union 4 to infinity. If you set x minus 4 equal to 0, get x equals 4, which is not only the RV, but it is also what is called an asymptote, a vertical asymptote. X equals 4. X equals 4 is really a vertical line. And that vertical line you cannot cross or touch. Because if I were to graph this function, we're going to graph one in a couple minutes. If I were to graph this function, it would come really close to this red dashed line, but it would never cross or touch. No cross or touching. Because this is the line, I say the gatekeeper. Which movie was it? Ghostbusters or something? You let nobody come through. It cannot be, I cannot have a point on where x is equal to 4 because it's not defined. So whatever we're graphing has to go either shoot up here or go down the other way. We're going to graph some in a minute. What I'm trying to say is that the restricted value is also the VA, which is called the vertical asymptote. So an asymptote is a line that the graph does not touch nor cross. If you touch the line, you really cross the line. Anyway, don't. Oh, that was kind of fun. Okay. Don't touch, don't graph over this asymptote. We need the asymptote again in chapter 4. So it's important that we get this right to begin with. So to find the vertical asymptote, you set the denominator equal to 0. We've already been doing that. That's also the restricted value for our domain. And the vertical asymptote, the VA, has to come in form of an equation. It's a vertical line, so you have to write x equals whatever that number is. The number, the RV, however you want to call it. But you cannot just say the vertical asymptote is 4. What does that mean? You have to say x equals 4. So if I look in the book, real quick, let's practice that. The book in 3.6 has find the vertical asymptote. Okay. Let's go to this one right here. Number 39 on page 399 says h of x is equal to x squared minus 1 over x squared plus x minus 6. And it's just asking you to find the VA. Find the VA. What did I say here? How do we find the VA? We set the denominator equal to 0. X squared plus x minus 6 equals 0. This is a quadratic. Now you can either factor that, or you can do quadratic formula to solve for x. For our purposes, all the problems I give you are in the book, they can be factored. How do we factor x squared plus x minus 6? X minus 2 and x plus 3. And in this case, we have actually two VAs. We have x equals 2 and x plus 3 equals 0, x equals negative 3. So these are your two vertical asymptotes. These are also your two restricted values. Let me just draw a number line. Because my next question is, that wasn't in the book, but I like them so much. What's the domain? Negative 3 is bad and 2 is bad. Everything else is good.
So it would be
Negative infinity to negative 3 union.
and then 2.
Negative 3 to 2 union. And 2 to infinity. This is a 3-part domain. You will get a 3-part domain if you have two restricted values. So between negative 3 and 2, you have y values.
So how does finding your vertical asymptotes differently from finding zeros?
You don't. It isn't. Yeah, it's the same. Same answer, yeah, so you're catching two stones with one answer, or two questions with one answer, yeah, whatever, yeah. Yep. The restricted value and the VA is really the same value, yes. Yes, it is, good point. Okay, vertical asymptote. Not that bad. We already know how to find the restricted value. Now, we also have horizontal asymptotes. There are two cases. There's actually 3 cases, but we only talk 2 cases because the third case you will learn once you go into calculus. And the cases of the horizontal asymptote, and that is y equals a number, depends on the degrees in the numerator and denominator. if the degree, meaning the exponent in the numerator, is smaller than the degree in the denominator, again, let me say it again. If the degree in the numerator is smaller than the degree in the denominator, then the horizontal asymptote is always y equals 0. So for example, f of x equals x over x squared plus 2. I just made that up. Let me give you a minute to write it all down.
When you put no in parentheses, you mean number?
No, numerator.
Oh, okay.
The degree in the numerator is smaller than the degree of the denominator. I just didn't want to write it all out. Then the HA, the horizontal asymptote, is always y equals 0. So that means you're not crossing or touching actually the x-axis, because y equals 0 is that horizontal line right on the x-axis. It's the x-axis. So this example here in blue, what is the degree in the numerator? The degree in the numerator is 1. What is the degree in the denominator? 2, right. So 1 is less than 2. Yes? That means the HA in this blue case is y equals 0. Don't look at anything else but the degree. Does everybody know where the degree is coming? Where did Ethan come up with those answers? Well, here is an invisible 1 here, and that too is the highest exponent. You got to look at the highest exponent, and that is the degree. That's the first case. The second case is if the degree in the numerator is equal to the degree in the denominator. Then the horizontal asymptote is the leading coefficient of the numerator divided by the leading coefficient of the denominator. And I'm going to give you an example in a second. The third case would be if the degree in the numerator is greater than the degree in the denominator. What happens is you have an oblique asymptote. Oblique asymptote is a linear, a straight line. And you find them from doing synthetic division again, but no worries, we don't do that. So if I were to ask you, let me just make something up. F of x equals 3x squared plus 2x minus 5 over 4x squared minus 6. What is the HA, the horizontal asymptote? What is the degree of the numerator?
2.
What's the degree of the denominator?
2.
So they are the same. Okay, we figured that out. So that's case 2. Now, who can tell me what is the leading coefficient in the numerator? And what is the leading coefficient in the denominator? Guess what? That is your HA. Y equals 3/4, and that is equal to the horizontal asymptote. Again, you have to write it in form of y equals, otherwise it's wrong. Let's see what 47 is. Do I like 47? Yes, I like 47. Okay, 47 is g of x equals 2x minus 3 and over 3x plus 5. And you are to find, actually, let me not ask the question. Let me ask the question I would ask. First of all, none of this is here. Find domain VA and HA. Okay, do it. What time? Oh, we're good on time. Oh, we can definitely graph one. Why not? And then we're going to review a little bit of parabolas. 3.1, you forgot all about those, right? How do we find the domain? You said 3x plus 5 equal to 0, and if you solve this, you get x equals what? Negative 5/3. So that just answered one question here. X equals negative 5/3 is the VA. Done you are. What is the domain?
Negative infinity to negative 5/3, and negative 5/3 to infinity.
Yep. See how good we're getting at this? Good thing we learned it in the last chapter.
The VA is the same thing as the restricted value.
Mm-hmm.
Okay.
Yep. Now we gotta look at the degree in the numerator to find the HA. What is the degree in the numerator? What's the degree in the denominator? 1. Okay, so what's the HA?
2/3.
What is the HA?
Y equals.
Thank you. Wink. Y equals 2/3. You can't be just saying 2/3. Okay, let's see if we can graph one. Not this one. Oh, yeah, why not this one? What's the HA?
0. Y equals 0.
Thank you. Y equals 0. Tony Ann, you know why? Colleen, you want to say?
Since the degree of the numerator is lower than the degree of the denominator, it's always 0.
The degree in the numerator basically is what?
0.
0.
Okay.
What happens if it's more?
Then it's an oblique asymptote. Then the asymptote is a straight line. We don't worry about that. It's either less than or it's the same. Yes?
So if they're equal, then it's a straight line.
No. No, Ethan was asking I think that's what you were asking. What happens if the degree in the numerator is greater than the degree of the denominator? Then you have what is called an oblique asymptote, which is can be a straight line, looks like so, and then your graph go away. Okay, colors go away. Then you graph either in here or in here. Could look like that, but we don't do that. Okay, I want to graph one. Why not? Let's graph number 27. F of x equals 3 over x minus 4. The first thing I would do is I would find the VA. and draw a dashed line. The VA in this case is what? X equals 4. 1, 2, 3, 4. So we know what happens at 4. I draw a dashed line, and for the rest of the story, I'm going to make a table. So I'm going to pick a couple values to the left of 4 and a couple values to the right of 4. I'm going to start with 0 because it's a y-intercept. 1, 2, 3, and then I'm going to go to 5, 6, 7. Why not? Because we can. Now, I just wanted to, before we do that, real quick, the parent functions is what some books call the reciprocal function, 1 over x. And 1 over x has a VA of x equals 0. X equals 0 is really this line here. That would be x equals 0. So you cannot touch x equals 0. And also, what else? What do we know about the HA? The VA is x equals 0. What's the HA? Y equals 0. So basically our coordinate system, the axes are the lines of no return. We cannot cross or touch. So one looks like so, and like that. That would be the graph of the parent function, which is 1 over x. If you plug in x equals -1, then you get a -1. And what did I just graph? X equals -1, then y is -1. I think I just graphed it the other way around. -1, -1, here you go. That makes more sense. It didn't look right to me. I'm like, what? That's why I plugged in values. Here you go. If x equals 1, then y is 1. Yeah. Right here. It looks like so. This is much better. Why? What does it matter?
I'm
What?
confused on why you would have it like that instead of like the first,
Well, the first one I had basically, I was looking at that point that didn't make no sense to me. I graphed it over here. So then, for example, I plugged in a -1 for x. So if I have 1 over -1, that means my y value should be -1, right? And this one would have been a +1, and that's why I knew that wasn't right.
Okay.
There you go. Let me get rid of it. Here you go. So then I'm like, well, 1 -1 is right here. You know, sometimes you do something and you think it's right, or do you think it's not right, and it just doesn't look right. So let's take a look at this one. If x equals 4, what is our y value?
Undefined.
No, if x... I did say 4, right? I meant 0. If x equals 0, what is our y value?
3 over -4.
So it would be -3/4. Yes. If x is equal to 1, let me write it out. 3 over 1 minus 4, which is 3 over -3. And what do we get? -1. If x equals 2, we get 3 over 2 minus 4, which is 3 over -2. So -3/2. If x equals 3, we have 3 over 3 minus 4, which is 3 over -1, right? Help me out, guys. Right. Okay. So how about 5? 5 minus 4 is 1, so at 5, it should be a positive 3. Right? And at 6, it should be a positive 3/2, so 1.5. And at 7, it should be a positive 1, right? Yeah, okay. Okay, let's plot some points. -3/4. Somewhere here. Hold on. 1, 2, 3. I can't graph today. 1 -1 is here. 2 -3/2 is 2 -1.5. And 3 -3 is somewhere here. So this graph, more or less, don't cross or touch the asymptote, looks down here like so. Here you go. Now we're going to do the other side. 5, 3, 6, 1.5, and 7 is 1. So this is kind of our mirror image and looks like so. There you go. Yep. So since our VA is 4 and our HA, I didn't ask you, but what is the HA here? Y equals 0. That's the y-axis. So I come really close to that, the x-axis, which is y equals 0. I come really close, but I'm not crossing it. There are, and the same thing over here. There are no x-intercepts here. If there was an x-intercept, it would cross the x-axis. There are none here. How do we show this algebraically? For a function to have an x-intercept, y has to be what? 0. So f of x is 0. So 3 over x minus 4 is equal to 0. That's what we would have to solve, right? Are you guys with me? I'm asking all these good questions. Now we're going to multiply by x minus 4. And what happens? 0 times x minus 4 is still 0. We don't get an x-intercept here. And we better not, because the x-axis is our horizontal asymptote. How do you like that? Logan, you liking that? Yeah. When I like something, you know where you see it. Yeah. Should we grab another one? What time is it? Yeah. We're good on time. Okay, so let me ask this question here. Last one, then we're going to look at the parabola, because you forgot everything about the parabolas, right? G of x equals 5x minus 3 over x minus 4. Okay. What is the VA? Oh, not again. 1, 2, 3, 4. The VA is 4. So basically what I'm doing is I'm transforming my coordinate system. The red one is now my coordinate system. The VA is x equals 4. What is the HA? What? 5. Y is equal to 5. How did he come up with that so fast? 1, 2, 3, 4, 5. So these are the lines. This is my new coordinate system, the red and the purple. Now let's plug in some values. 0, 1, 2, and 3 again, and yeah. I keep getting all these emails. I need to turn this off because it's distracting. How can I turn off so I can't see my email while I'm using my iPad?
If you pull up the bottom menu,
Uh-huh.
you should be able to put it on do not disturb.
Oh, okay, I will do that.
The moon symbol.
Yeah, because I'm thinking about 3 different things here. Okay, I will do that. If x is equal to 0, what is y?
3/4.
If x is equal to 0, you have 5 times 0, that's -3 over -4, which is 3/4. Okay, if x is equal to 1, 5 minus 3 over 1 minus 4. 5 minus 3 is 2, if I'm not mistaken. And 1 minus 4 is what? A -3. -2/3. If x is 2, we have what? 10 minus 3, which is 7. 7 over -2?
Yes.
Guys, come on. Here, you do the next one. Why am I doing this?
-12.
Okay, finish it up. I will see if I can plot this here. 3/4. That's somewhere here.
Then 5 is 22.
22? What? Okay, let me do one thing at a time. 1 -2/3, so somewhere here. 2 -3.5, so somewhere here. And -12 all the way down here. Maybe we should have picked... Can somebody do -1 for x? What? What is it?
It's 8 fifths.
8/5. That's a little bit over 1. So, and eventually it goes up. So we're gonna, not a good graph, but we're gonna not cross the 5 and more or less looking like so. If x is 6, what is y?
27 over 2.
So 13.5. Okay, we're going down. Somewhere here. And 7?
32 over 3.
Well, you get the idea. We're going down. That's for sure. So this looks somewhat like this. Here you go. Beautiful. I like it. Not really, but just bad dimensions. You get the idea. So, VA, everybody good? HA, everybody good? Graphing, make some points in between to the left and to the right of the dashed line. Let's take a look at the parabola 3.1. 3.1, we talked about parabolas and everything that we want to know about a parabola. So I can ask you 20 questions. I can give you a parabola, and then I ask you 20 questions. So let's take a look at this one right here, real quick. Use photo. So, here you go. Beautiful parabola. And this is 2. Okay. Is this a function?
Yes.
Yes. What's the domain? What is the range? 2 to infinity. What is the vertex? 1, 2. What is the axis of symmetry? Thank you for saying that. Beautiful. Okay, do we have a minimum or maximum? What is the value of the minimum? 2. What is the y-intercept? 0, 3. Do we have any x-intercepts? None. Where's the function increase? Increasing. Where's it decreasing? Negative infinity to 1. That's about all. What else did we talk about?
Question.
Yeah.
I
No,
forgot-
it's not.
I forgot about axis of symmetry. How do you find that again?
The axis of symmetry is the x value of your vertex.
Okay.
The vertex was 1. So, no, it's not 1-to-1, but we're not asking for inverse function here. We all can see that obviously it opens up. I'm not going to ask that question. I think that's all we have. How about if I give you a function that is 2x squared minus 8x plus 5, and I ask you what is the vertex? How do you find it? You have to use the formula negative b over 2a. What is b in this case? B is negative 8, and there's a negative with the formula, so be careful about the signs. Divided by 2 times a is 2, so this becomes 8 over 4, which is 2. So the x or h value of your vertex is 2. How do we find the y value?
You said x equal to 0?
No.
Oh.
You plug it in. Now you find f of 2. F of 2 is 2 times 2 squared minus 8 times 2 plus 5. 8 minus 16 is a negative 8 plus 5, so I assume would be a negative 3. Okay, maybe we can sketch this, so I could be asking you to sketch it. X, Y, 1, 2, 1, 2, negative 3, 2. So our vertex is right here. And to sketch it, we really want 3 points. So another good point would be the y-intercept. What is the y-intercept here?
You have to plug in 0.
Right? 5. If x is 0, then all the x's go away. All you have left is 5. So 0, 5 is 1 point. What is the AOS? X equals 2. So now, if I draw my vertical line, this is my line of symmetry, and I have 0, 5, now I can find the mirror image, which is what? 2 units on the other side of my AOS right here. And what is that point? That point would be 4, 5. And then you connect the dots, little vertex, curvy action, and off you go. Ooh, I like these problems. And then, of course, what is the range? What's the domain? What is the vertex? It's a minimum, the value, okay. I could be asking what's the x-intercepts, not in this case. You would have to factor it or quadratic formula. This one cannot be factored. Are we good on the parabola? Now, if your parabola is in this form, what is the vertex here? 6, 10, because that is in vertex form already. Does this parabola open up or down? Because I put a minus in there. That parabola opens down, so do we have a max or a min? I already wrote it down. The value of the max is 10. What's the axis of symmetry? X equals 6. Yes. Any questions? So, test some parabola stuff, of course, what we did. Also, graphing polynomials. Oh, let's graph one. Last one. F of x equals x minus 2 times x plus 3 squared. What's the degree? The degree is 3. What are my zeros? Add 2, 1, 2, negative 3. Which one crosses? The 2 crosses. And what is the y-intercept? Come on, y-intercept. It's down here. Negative 18. Set x equal to 0. 3 squared is 9 times the negative 2 is a negative 18. What's the end behavior? The degree we said was 3, and the leading coefficient is positive. So what's the end behavior? Down and up. Degree is 3, odd number. So down and up, different color. So we're going to go up here. We're going to have to hook up with the 18 negative, that is. We're going to touch, and we're going to go down here, like so. More or less. Again, what I said before, I'm not too interested how far down all of this goes and whatnot. Oh, I like the Christmas colors here. Okay. Graphing a polynomial. Degree, multiplicity, the whole 9 yards. Have a good day.
So
Any questions?
why do they